Hey everyone, I wanted to do a quick video talking about STM32 CubeMX because when I've been trying to get into this in the last week or so, and there's a lot of things I found online, and they kind of mention Python scripts and how to build projects yourself using actually getting the FreeRTOS libraries and all this, and I think it's a bit outdated. And I haven't found anything on YouTube relating to this stuff. And this is kind of where I went to, or where I go to a lot of the time to find these kind of this kind of information. And since there wasn't anything there, I thought I'd make a really quick screen capture about just the basics of using STM32 to get like an FreeRTOS project running up in a couple of minutes on any of the STM32 boards. So essentially, STM32 Cube, all it is a code generation platform. So you can go in, and it supports all these different boards. So you've got all these ones. So my board is here somewhere, but I'm going to sort for it. So I am nuclear, the one I'm using at the moment. It also has, and so you can sort by peripherals as well. So this is my board with Ethernet. So, and then also up here, this here is a really handy option if you're just doing a real basic project. You just want to get up and running quickly, and you don't want your peripherals to kind of clash with each other. So this will, if using this, you can do this all yourself manually later, but it's kind of a good way of guaranteeing that your board is going to run with all the set peripherals from the get-go. So you double click on your board and it should generate a project now for you. So this is essentially the microcontroller, as you can obviously see, and all the pins. So for instance, if you want to enable a GPIO pin, it's as simple as clicking on the pin and enabling what you want it to do. So this can then all be monitored. So if you set that GPIO pin and you want to change the pull-ups or label it, you then go to configuration, go into GPIO, and then this pin here. So I can label it to whatever I want. But where STM32 comes in as such a powerful tool is that you can configure all the peripherals, but then you have these like stacks, or the middleware as they call it. So you got FreeRTOS. So getting a completely built project with all the libraries, all the config files, everything set up is just as simple as clicking that. And then essentially this will build a project that will run from the get-go. So then in configuration, you can configure FreeRTOS, and this in here is essentially your FreeRTOS config file. So you enable timers, you would enable them here. You can do all the stuff later in the code editor, but I mean, if you want to do it here, it's an easy way to get this code automatically generated for you. So you can also do things like you can add tasks, you can add in some timers, you can add a timer here, it's all the default stuff, add a semaphore. So so that will generate all the configs and everything, the init code for that. The clock configuration is really also a useful tool. It kind of just makes sure that when you have all these different peripherals going that all require different clocks and whatnot, that this all calculate like a stable solution for the microcontroller and the clock configs. So this is a useful thing. You don't really need to use it that much, but occasionally you'll get a little red arrow, a little red cross up here, which means you have to go here and resolve some issues. So the project settings, call this test, whatever. And so the toolchain that I use is this one, the STM32. So this is designed to be used with STM's system workbench. So where these old things online kind of use these Python scripts and whatnot, if you just generate your code now through Cube using that toolchain, generate my code. Oh yes, I should probably not use system ticks. I should use a hardware timer for FreeRTOS. Generate my code. Then if you've got open project, it will pull it into, this is the STM workbench. So this is it here. So I can build the project. And if you look in here, all the init codes have been done. So these are all the peripherals by default. You've got your HAL, so these are the HAL libraries. There's the timer I created, and there's the semaphore I created, and there's that second task and the default task there. And they're all down here. So there's all the tasks and the callback for the timer, all the GPIO init code. I mean, you can edit this stuff yourself, but yeah, I mean, it's easy enough. And if you go into FreeRTOS config, you can see, for instance, where I enabled timers is here. So that's been enabled in the configs as well. But where Cube is really comes in handy, or I find, for instance, is I'm working on a project and then I want to throw in like a half dozen GPIO pins, or I want to throw in an SPI device, and it's really easy to kind of regenerate this init code for it, and kind of set the code templates that you want in a matter of like seconds. I mean, you can do this stuff manually, but it really is just a time-saving thing. So the structure of the code they generate is that have all over the place is kind of like user code sections, and these are really important because anything I write in here will get preserved. And so if I write another comment here, so this one here is outside of the user section, the 3/, and if I go back to Cube and I want to say include now an SPI device, let's make sure I saved my main. Yeah, I did. Okay. So I created an SPI device. Now, if I, with this setting here in code generator, keeping user code when regenerating means that I've added the SPI device and I want to regenerate my kind of like base code. So boom, I've regenerated it, and in here it'll update the files. And you can see here the comment that was outside of this section has been deleted because it's been overwritten, and my original code's been kept. But if I go up to my inits now, my SPI init code's there. So then if I clean this and build it again, it will now build and it will include all of the SPI init code, and then this can be used like normal. So it's quite handy, but then also it's got its downsides. Like I usually like to keep my tasks in separate C files, kind of to modularize my code a bit more, and then these standard task functions will always get generated. So normally I will have to kind of, after I regenerate, come in, comment them out, and then they'll get run from my separate C files. But so this is just a basic overview of everything that Cube can do and how it can be really useful in quick project generation, and then also later on for just saving time on creating just basic init code. And it also gives a nice template, really well structured. So thanks for watching. I'm going to try and do some more videos, just quick screen captures again on various more in-depth components of Cube and using it with the HAL libraries and RTOS and everything. So I hope this helps some people, and that through this you can get a quick, easy project going. I should probably mention that you can also run it by going run as, and if I plug a board in here, 1 second. So run as STM application, there's the board. Wait, what? Because I've commented out my functions. All right, quickly get rid of these, put them back in, so I can then run as that guy. And then also like all the config stuff's already there for debugging, so I can debug, simple as that. I mean, with the system workbench and the MX, it's kind of like a zero hassle solution, so you can then step through all the code like you would. But that's the last thing. Thanks for watching. I hope this helps.